Now we're going to get into some areas of a circle that are very simple, but you have to pay attention. One of the things about circles and where we're going now is every topic that we introduce on circles is brand new. Yes, we use some things from geometry that you already know. For instance, there's an awful lot of triangles when we deal with circles. Why? Because you can draw triangles within circles very easily. There's an awful lot of right triangles whenever you deal with circles. You draw polygons within a circle, then you can certainly draw triangles. You draw regular polygons within a circle. There's all kinds of ways for us to deal with those regular polygons by drawing triangles. Using trigonometric ratios, using all kinds of things in which we can solve those triangles, find solutions, find links, find arcs, and so forth. So what we're doing is you're really putting together multiple types of figures and multiple types of shapes, finally, in this geometric world in which we live. Okay, we're still working in a two-dimensional world. We haven't even entered a three-dimensional world. We're still working in a two-dimensional world. So as we go in and we introduce a new topic, it's new to you, so you're going to have to spend just a little bit of time looking at it, reading it, and understanding the vocabulary. And this is what we have in this section. It's called Inscribed Angles. Let's talk about what an inscribed angle is. Inscribed angle is an angle that has its vertex on the circle and its sides are chords of the circle. Vertex is on the circle. That means it's on the round part of the circle. Its sides are chords of the circle. Okay? So let's just look over here. Angle ABC is an inscribed angle. Why? Because its vertex, the center letter of the angle, name of the angle, is on the circle, and its sides, BA, side BC, are chords of that circle. Wow, you mean when we had angles, we really could be using and looking at that and putting those on a circle and they could be inscribed? Sure. Okay, that angle is contained within that circle. All right, so this is called an inscribed angle. Now that, you can put A, B, and C anywhere on that circle. So it can look any way you want it to. Center right here is there, but the center could be over there. Okay, or it could be on the circle. It could be on one of the chords. So the center can be anywhere. Everything we're talking about is still true. ABC, angle ABC is an inscribed angle. Now, angle ABC also intercepts arc AC. So this angle ABC creates arc AC on the circle. It intercepts the circle at AC and creates an arc. Okay? Also, arc AC is intercepted by angle ABC. In other words, how is arc AC created? It is created by the angle that intercepts it. So arc AC is intercepted on the circle by angle ABC. Intercepted. The circle is broken. It's stopped. Okay? So we can define, we can look at arc AC. This terminology is something you need to get familiar with. Angle ABC intercepts arc AC. Arc AC is intercepted by angle ABC. Now, let's start talking about theorems, and we have several we need to look at. First one we're going to look at is an inscribed angle theorem, using the symbols because you need to be familiar with them. What it says is, a measure, actually we just need to change that to the measure, because I started that out a different way. So let's just change that to the measure, okay? The measure of an inscribed angle, don't forget the symbol here, of a circle is 1/2 the measure of the arc it intercepts. Huh? Wait a minute. We're used to central angles where the arc, measure of the arc, the degree measure of the arc, and the degree measure of the angle is one and the same. Yeah, because that's a central angle. Central generates, comes from, has its beginning in, and its vertex in the center. An inscribed angle has its vertex on the circle. Therefore, what we do is, oh wow, this arc here is twice as big as the measurement of that angle. Okay? Oh, I'm sorry. The angle is 1/2 as big as the measurement of the arc. The measure of an inscribed angle of a circle is 1/2 the measure of the arc it intercepts. The converse is also true, of course. The measure of an intercepted arc is twice the measure of the angle that intercepts it. Notice we're using this term, intercepted and intercepts. Okay? You need to be familiar with those terms. This is the definition of an inscribed angle. This right here is very, very important. Because everything else we're going to talk about, we're going to introduce, and the concepts we're going to introduce in this section of inscribed angles is based upon this right here. Okay? Inscribed angle theorem. Measure of an inscribed angle of a circle is 1/2 the measure of the arc it intercepts. In the converse, the measure of an intercepted arc is twice the measure of the angle that intercepts it. Very important concepts as we move forward in our talking about circles. Okay, let's talk about another concept on inscribed angles. Now you'll notice that what I've done is I left the definition of inscribed angle up here so that we can refer to it. So let's look at this other one. Inscribed angle, an angle that has its vertex on the circle and its sides or chords of the circle. So another concept. We have multiple angles. They cross up, look all kinds of ways. They can get confusing really quick. So you have to pay real close attention. We're looking here at this. Angle ABD. Start at A, go to B, come to D. Angle ABD is congruent to angle ACD. ACD. Notice that ABD comes over here, has its vertex there, but guess what? They both start at A and they both end at D. They start at A, they end at D. Start at A, end at D. Or you can say they start at D, end at A, start at D, end at A. They are congruent because they intercept the same arc, arc AD. Okay? The endpoints of their sides are the same. They intercept, they create the same arc on the circle. Therefore, they have to be congruent. They have to have the same measure. If I lay this arc, this angle on top of this one, they're going to be congruent. The same thing. Angle BAC is congruent to angle CDB. Why? Well, this one starts at B, ends at C. This one starts at C and ends at B. Oh, could we turn those around? Yeah, we could say this is angle BDC. We could say this is angle CAB. They start and end the same place. Therefore, they are congruent because they intercept the same arc, arc BC. Okay? Anytime two or more angles intercept the same arc, or congruent arcs, they are congruent. Same thing. Two arcs are congruent that are intercepted by the same angle. Okay? Arcs that are intercepted by the same angle or congruent angles have to be congruent. So let's go over here. A different picture. This one is sort of obvious. Both these angles create the same arc AD. Both these angles create the same arc BC. Now let's go to where we have two different angles that create two different arcs. And we're told that the arcs are congruent. Arc AC is congruent to arc DF. If they are congruent, then the angles that create them are also congruent. The angles that intercept them are congruent. Therefore, angle ABC is congruent to angle DEF because they intercept congruent arcs. AC and arc DF. We can also say that the converse is true. If we know that the two angles are congruent, then we know that the arcs that they intercept have to be congruent. Same thing, back and forth. The converse is also true. Okay? The converse is also true. What's the converse of that? If I have two congruent angles, then the arcs that they intercept are also congruent. The arcs that congruent angles intercept are congruent. Okay? The angles that intercept two congruent arcs are also congruent. Okay? Some more things and concepts you need to know about inscribed angles.